So in this video, we're going to look at how we perform the second sub-step under obtaining the regression model. It is called testing the quality of the sample model. So it's very similar, exactly the same step as our simple linear regression model. So usually we call this step as measure the goodness of fit of the model. Measure the goodness of fit of the model. So here I want to revisit this equation again because this is the one we use to guide us to creating the statistic called coefficient determination, or R squared, to measure the goodness of fit. So SST equal to SSR plus SSE. So in this video, I won't spend more time to explain why this equation holds. So if you forget, please go back to chapter 14 to revisit this part of the video to understand why SST equal to SSR and plus SSE. So if you look at your handout, chapter 15 handout important. So you will notice that this is our first page regression output for the Spark Club we worked on. So for this case, and we just look at where to find SST, SSR, SSE. So actually, it is exactly the same place we found for the simple linear regression model. It is in the second table called ANOVA table, and there is one column called SS. So the value under SS are my SSR, SSE, and SST. So go ahead to label your handout. As I said, you might need to use it when you work on your homework. So, in a very similar idea, we created this statistic similar as chapter 14 called R squared and also called a multiple. Here we call it multiple, but basically they're the same thing. It's my R squared, so we're using SSR divided by SST. So since we have the simple linear, we have the regression output, please don't calculate by yourself. So don't calculate. So here I just show you this right. This is right. The reason because we can directly find from the regression output. So the regression output. So it is the same place as your simple linear regression model. It is under the regression statistics called R squared. So 0.7164847. So that is my R squared for this Spark Club example. And so the reason we go through a little bit fast here because it's the same as chapter 14. So what we're going to focus on is the difference. So what's the difference between the measuring the goodness of fit between simple linear regression model and multiple linear regression model? So that is the next statistic we're going to discuss. So this is called the adjusted R squared. Adjusted R squared or adjusted multiple coefficient of determination. So why we need this one? Because based on the statistic modeling, so statistician, they notice that if you will be including a lot of x variables, and so the more x variable you have, the larger R square you will get. So basically means if you are using R square as an indicator to measure the quality of your sample model, so that R square will have intention to ask you to add as many variables as you can. So what's the problem? So think about if you ask a design survey asking 100 questions, another survey only asks 5 questions. What is the difference? So difference will be the time you put in, the energy you put in. So being a statistician, we usually work with a lot of businessmen as well. The time is money. So you don't want to waste your time to ask people filling a bunch of questionnaire. So you only want to ask the question that is highly related to your Y variable, right? So that's why if you're only using R squared to measure the quality of the sample model, sometimes may not be the best idea. So which means we have to have a statistic that can be penalizing you by using too many x variables. So that is our adjusted R squared. So adjusted R squared. So the adjusted multiple coefficient of determination or adjusted R squared compensate for the number of independent variable in the model. So basically, this if you have too many the x variable, your adjusted R squared will start to decreasing. So look at my adjusted R squared. We usually use R squared and the subscript A indicating that is considered as adjusted. And adjusted R squared equal to 1 minus etc. So the P is the number of the x variable you have in your model. P is the number of variables you have in your model. And the R squared is the R squared we learned just like 2 slides ago. So you can see adjust R squared related to R squared and related to the number of the predictors. So let's think about if P increase, how adjust R squared will change. So look at if P increase, your denominator will start decreasing, and then the whole ratio will be increasing, and then 1 minus r squared always is positive. So basically on the right hand side, as p increasing, the right hand the value after the minus sign will increasing. So 1 minus an increasing number means the just r squared will decreasing. So that's why I said the more variable you have means the p value will be larger, so your adjust r square will go down. However, it's also considering r square means they are still considering the statistic we learned in the chapter 14. But now we just need to penalize if the value is too large, if you have too many adjust r square. So you don't have to memorize this formula. Actually, I encourage you, don't try to memorize this formula, because we actually can find the value, the just r square's value from the Excel output. So where is the just r square? So it is right under your r square is the just r square. So did you notice that for this SPAR club example, this is a little bit smaller than r square? The reason here is because we have more than one predictor, or more than 0 predictors. So if you have one predictor, just r square will be definitely smaller than r square. If you have more than one, it will be smaller, even smaller. And so that's why you got the 60.30%. 60.30%. So this is the just r square. So some student will ask, when should I use the just r square? So if you only consider one variable, if you try to only measure one variable, if the sample model is good, you can just use r square. It doesn't matter. However, if you are comparing models, because sometimes you have teamwork together, somebody recommend, oh, you should include the 3 predictor, somebody say, oh, we should include 5 predictor. So how will you know which one is better? So if you are comparing 2 models with a different amount of predictor, you have to use adjust r square. You have to use adjust r square because you want to put both model in the same measurement platform. Because as I said, if you use r square, you will know that they always intend to let you choose the model with more predictors. But sometimes that might not be a good idea, because as I said, more variable means more time going to be consumed collecting information. So when you comparing model, you are using adjust r square. If you're only analyzing one variable, you can just use r square and adjust with r square fine. But again, you don't need to switch to adjust r square if you only use considering one variable. So make sure you're gonna put a label, take note on this handout by yourself, because again, you're gonna use this handout to guide you through your homework, and so get familiar with where to find the statistics. It's very, very important.